All right, awesome. So today we struggle a little bit with this question, all eyes on the screen. So it says, students taped a rubber band to a box of washer. I have a picture here that kind of shows me what's going on in this experiment. If they say, then they drag the box across 4 surfaces using the rubber band. The students are using the distance the rubber band stretches to measure. Measure is an important word that I know. What is my variable that measures, Miguel? What is the variable that measures? Yep, you're looking at the right spot. Nope, you were. The one that measures. The dependent variable. Dependent variable. That's the one that measures. So it's measuring the amount of friction. So I'm going to put here on dependent variable, amount of friction. Fix it if you need to fix it. The IV is what we're changing here. It's showing me in this picture that I have different type of surfaces. Surface A, B, C, and D. So what's my independent variable, Cadence? Yes, the type of surface. So I'm going to write that down. Type of surface. That's my IV. My IV is what I change. And if it helps me more, I can also write it down next to it. I can write down IV is what I change. DV is what I measure. And CV is what stays the same. What is staying the same in this experiment, Brenda? What's staying the same? What are we just keeping the same in the experiment? We know that we're changing the surface. We know that we're measuring how much the rubber band stretches, which it tells me about friction. What are we keeping the same? Go ahead, Miguel. The rubber band is the same one, right? We're not using a very loose one and a very tight one. We're using the exact same elasticity on the band. What other thing we're keeping the same, Cadence? Yes, the box of washers. Absolutely, box of washers. So based on my testable question, I know that how does IV affect the DV? That is my guide to write an exemplar testable question. So what should be my testable question here? Raise your hand. What should be my testable question here? I have identified all my variables, so I should have all hands up. Because it's how does IV affect the DV? And I already have the IV here and the DV here. So I should have 100% of hands up. 100% of hands up. Waiting for 100%. We all know 100% of hands up. Kaylee, what is my testable question? What's the IV, Kaylee? Type of surface. How does the type of surface affect, because again, we are changing, we're changing what I have, I'm putting the IV and the DV. So how does the type of surface affect the DV? What's the DV, Armando? Which is, in this example, is what? The amount of friction. Affect the amount of friction. That should be my answer for number 1. I have identified all my variables, and now I've written a testable question. And it says, how does a type of surface affect the amount of friction? It is very similar to the experiment that we did today. But instead of having 4 surfaces, we had 3. We had a fabric, we had a smooth surface, and we had sandpaper. So let's make sure that we're always identifying the variables in our experiment. I'm going to give you 30 more seconds to finish up. Okay, let's move on to number 2. Number 2, it says, Chad wants to determine how deep, so this is going to be my testable question because I know it starts with a how deep a needle will travel when he pushes it gently. This is my testable question. So now that I know this is my testable question, I'm going to identify the independent variable. What's the independent variable, Citlali? What's the independent variable? What is our keyword for independent variable? What is our keyword? Change. Thank you, Chance. Change. So what are we changing here? I have a very key word right here. Citlali. What is my independent variable? I've circled something that's going to be different there. Yes, the pieces of fabric is my IV. And so what is my DV? What am I measuring? Brenda, what am I measuring? What do I want to test? Go ahead, Curly. Absolutely. How deep the needle will travel is my DV. That's what I am testing. I'm testing which fabric is going to have the needle go deeper. So we know that we can only have how many independent variables? Shout it out. How many independent variables can we have? Shout it out. How many independent variables can we have? It's in your IVDVCV chart. Shout it out. Go. 3? Let's say it one more time. Only 1. Shout it out. Go.
3.
Why are we saying 3? IV. What I'm changing. Can we change multiple things in an experiment?
No.
Absolutely not. So again, how many independent variables can I have? Go. 1. Only 1. Only 1. That's it. We can only have 1. So, since we can only have 1 IV, let's read which one has only 1 independent variable. It says, push the same needle into the same piece of fabric, multiple trials with the same amount of force. Well, if I have the same piece of fabric, is that testing my independent variable, my independent variable of the different fabrics? No. So this can't be my answer. For B, it says, push different needles into different pieces of fabric. Now I have 2 IVs. These cannot be possible because I have 2 IVs. Absolutely not. We can only have 1. My third option says push different needles into 3 different pieces of fabric, multiple trials with different amount of forces. So I have, again, 2 independent variables. That's not possible. We can only have 1. And so lastly says push the same needle into 3 different pieces of fabric, multiple trials, same amount of force. Absolutely, this is what's going to help me with my experiment. Because I have my IV here, and then I have my DV that I'm testing, which is how far it will travel. Okay, I'm going to go collect it, and please fix it if you need to do so.